Now, I thought before we go on to our last few topics, I would use this that is available in your textbook to indicate as sort of a review of things, and they call it an integrated review, all the different techniques of things we need to do. So for instance, in number one, this is the multiplication of monomials. Another example. This is to square 4 and then apply the negative sign. Here we're squaring a negative 4. Now we could use the traditional way or FOIL. FOIL. Now notice this is not FOIL, this is addition of like terms. Addition of like terms. This is division and simplification. Now this is squaring this. We're going to square the 12, get 144. And here we're multiplying these. We're going to cube the 4, then multiply these. We're going to FOIL this, then multiply by 3. FOIL this, multiply by 2. Multiplying exponents here. Again, there's 3 to the first, so this is going to be 3 to the third, which is 27, x to the 27th. Here, this is subtraction. This is subtraction. We remove this parentheses and change these signs and just combine like terms. Here we're combining like terms. That's special product. So again, lots of things going on here, showing you the kinds of things you can expect as you go into your testing mode. But if you're doing your practice and your quiz-mes, you're staying ahead of the game, so to speak. So now we will be moving on to topic 5, which is negative exponents and scientific notation. Now we did exponents in the beginning, but now we're going to treat these negative exponents. So a typical negative exponent would be like this, x to the negative 3. Well, what does that mean? Well, if we had taken this, brought it up, and when it crosses this division bar, the sign of the exponent changes, that would give us x to the negative 3. Now, suppose we did it the other way. Instead of taking it up, we brought it down. And remember, there's a 1 there that stays up there in the numerator. We then have a 1. This 2 crossing this division bar changes its sign, so this becomes x to the third. So whether you can see it or not, these two are equivalent because they started off the same way. So x to the negative 3 is actually, in its positive exponent form, 1 over x to the third. And they're showing it to you here as well. And I think the rule is going to come up here shortly, so I don't have to write it. Okay, there it is right there. So if we see a to the negative n, that is equal to 1 over, and again, taking this down to the denominator, the sign of the exponent changes. So these are equivalent. And then in these next few examples, they're asking us to simplify if we can. So let's do these. This is going to be 1 over 3 to the second power. Bringing that down, that becomes 1/9. Now, tricky here. Watch this. This is the base of this exponent is only the x. So the 2 stays in the denominator. X comes down, changes the sign of the exponent. Now, by the way, 2 to the -1 is just another way of writing 1/2. So again, a 1 in the numerator, the 2 comes down, and the exponent is there. This is another way of writing 1/4. Again, the 1 in the numerator, the 4 comes down, and then now we want to add these. So this is going to be 2/4 plus 1/4 equals 3/4. So that was a little tricky too. Again, everything comes down, 1 over -2 to the 4th. That's 1 over, and then since it's an even number exponent, this will become a positive 16. And then this just is 1 over y to the 4th. And they have it all worked out here for you as well. Let's do the practice and raise it up a little bit too. So this is 1 over 5 to the 3rd, which is 125. The 3 stays up, and this is y to the 4th. This is 1/3 plus 1/2. So that becomes 2, 6 plus 3, 6 equals 5, 6. This becomes 1 over this squared now, which is just a positive 25, and this is 1 over x to the 5th. Now, keep in mind, a negative exponent sort of only refers to where it is, whether it's in the numerator or denominator. It doesn't really apply like it's a negative number. In a way, it does too, but anyway. All right, let's go on here. Some interesting things, look that over. Now notice the difference. Here we have a to the -n is 1 over a to the n. If we have it in the denominator as a negative, we move it up to the numerator. Remember, this is over 1 here. Okay, here they want us to write only using positive exponents. Okay. Are they asking us to simplify? Yes. So here we just move that up. That's going to be x to the 3rd. Move this up. This is going to be 3 to the 4th, which is 81. Now, for something like this, just switch them around. It becomes q to the 9th, p to the 4th. And the same thing here. This becomes 2 to the 5th, and this becomes 5 to the 3rd. 2 to the 5th is 32. 5 to the 3rd is 125. And we could do these two here. Let's see. S to the 5th, 2 to the 3rd equals 8. and this is y to the 5th, x to the 7th. This is going to be 3 squared, 4 cubed. 3 squared is 9, 4 cubed is 64. All right, let's go on. Simplify each expression. Write answers with positive exponents. Well, here we're bringing this up. There's a 1 there. This then becomes 1 plus 2, or y to the 3rd. When this crosses this division bar, the sign changes, and we just add them. And this is going to be 3x to the 4th. Now, since we want positive exponents, this is negative up there. We have to bring it down. So we're going to add 5 to the 7, so x to the 12th. Now, an interesting thing that they'll mention to you sometime or other, that when we have a fraction like this, and it's to a negative exponent, we can make this a positive exponent just by taking the reciprocal of the fraction, which then becomes 3/2 to the 3rd. So 3 to the 3rd is 27. 2 to the 3rd is 8. And they have that all written out here for you. Okay, let's go on. Simplify each expression. Oh, we did that already. All right, here's a summary, a nice summary of all the rules of exponents that we had from the beginning section and then including this section. So you can go over those to check them out, and then we'll put them in action here. Again, we want all of our results in positive exponents. So letter A here, we're going to go y. Now interestingly, the rules of multiplication and the signs apply. So this is going to be a -3 times a -6 gives me a positive 18. Now this is going to end up with a negative z to the -36 that I'll put in the denominator as a positive 36. Now here we have to simplify first. So it's going to be 2 to the 4th, which is 16x to the 12th times x to the 1st over x to the 7th. Okay. Well, this is going to become x to the 13th. Let's make that a 13th here. We did away with that. And then we end up with 16x subtract 7 from that leaves me with 6. And there it is right there. Now again, we have a fraction with a negative exponent, so we can just flip that around. That becomes b, and this is 3a to the 2nd. So this becomes b to the 3rd, and then the 3 to the 3rd is 27, and then 2 times 3 is 6. Right there. All right, I'll clear this up a little bit so we can see it better. Now what do we have here? And we want positive exponents. Well, this is going to go up and it becomes a a negative 1 and a positive 3, this is going to be 4 squared. I'll expand that later. Now, this is negative up here, so I'm going to bring it down, add it to the 2. This will give me x to the 5th there. Going to bring this up, and this is y to the 7th. Because there's a 1 there, a negative 6 becomes a positive 6 and 1. And this is just going to become a 16, so I guess we can change that now. And that should be good for letter D. Yes. All right, letter E. Okay. Now we're raising a negative 2 to the 3rd power. So that's going to give us a negative 8. Because negative 2 times negative 2 times negative 2 is negative 8. This is going to be x to the 9th, y to the 3rd, and this is going to be, on the denominator here, x to the 3rd, y to the negative 3. So we're going to simplify a little bit. This stays as a negative 8. We subtract 3 from 9, we get x to the 6th. And we move this up. This gives me y to the 6th as well. A negative 3 moved up becomes a positive 3. And these all check out. Good. Okay, as we move into scientific notation, you can read this over, but basically it's to take very large numbers or very small numbers and put them into some power of 10 by moving the decimal point over and then writing it in exponential form as powers of 10 that we see down here at the bottom. So, again, read it over. It gives you more detail. But basically, our decimal point is right there. We're going to move it over 3, 6, 9. Times 10 to the 9th. The number of decimal places we move it over to make it a number between 1 and 10. So we've taken this very big number and written it in scientific notation by moving the decimal place over to make it a number between 1 and 10. Now, for this one, wow, let's see, there's 3, 3, 3, 3, 3, 3, 3, 3. I'm moving the decimal point right there. Now, when I move the decimal point to the right, it becomes negative powers of 10. So 3, let me just say 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 is 24. So this big number in scientific notation is this. And we're following this protocol down below. And here they summarize it as well. That's what we had up there. Okay, to write a number in scientific notation, there are the steps. Let's see it in action. So, We're going to start right here, 3, 6, 7, 8. So 3.67 times 10, and I said I moved it over 8 places. Now I'm going to go 3, 6. 3.0 times 10 to the negative 6. 3, 6, 9, 10. 2.052 times 10 to the 10th. And here is 1, 2, 3, 4, 8.5 times 10 to the negative 4. Now, notice putting it into scientific notation is putting your original number to moving the decimal to make it a number between 1 and 10. And then that is the power you put your 10 to. And if it's a big number, the exponent will be positive. If it's a small number, your exponent is negative. Now, to do the opposite of this, to go from scientific notation, you just undo it. Here it's saying you're going to have how many places to move this decimal? 8. Well, there's 2, so you would have to add 6 zeros to get your 8 places, and it works this way. Let's see it in action. So here's 3 places. We have 2 here already, so we have to just add 1 0. So let's see these here. So it's 1.02, and we have to have 5 places to move the decimal point. So we're going to add 3 more zeros because we're going to move it 5 places. Now here we have to move the decimal 3 places. So we have 7.358, and we have to move it how many places? 3. So we have 1 already, so how many zeros? Well, we have to add 3 zeros to move it 3 places. And we usually add an extra 0 so that we can place our decimal nicely. But we're only adding 3 decimal places. Here we're going to add 7. So there's 1 there. How many zeros? 6. Here we have 1. So 3.007. How many decimals? Got to move it over 5. There's 1. So we have to add 4. 1, 2, 3, 4. And then we add an extra 1 so we can place our decimal. Okay? And you'll be practicing this to see if in fact you've mastered it. But this should be an easy thing here. Now for example 7, what they want us to do is to work on performing either multiplication or division that then later we will put it in standard decimal notation. And the protocol for doing it would be to multiply your 8 and your 7, get 56. Then multiply your exponents here by adding. This gives you a negative 3. Now you have 5, 6, our decimal is there, times 10 to the negative 3. Well, how many places do we have to move that decimal? It says here 3. So we have 2 places to move it. We're going to need 1 0 so that we can move it 3 places and then add another. Okay? And that's what we get. Now when we divide, we do the same thing. 6 goes into 12 twice. We're going to bring up our negative 3 and the 2 and get a 10 to the 5, 10 to the 5th. Now we have 2 times 10 to the 5th. We have to add, our decimals here, how many decimal places? 5. So we have to add 5 zeros. 2, 1, 2, 3, 4, 5. And we could put a comma in there if we like. Okay? Again, practice and getting your mastery. And graphing calculator and vocabulary check. We're wrapping this up with 26 or so minutes.